Okay, so we are back. We are doing in Math 2 4.6, and we're finishing off the last little bit of this lesson. And it's a really good place to start a review because you guys have a test. So the directions for this one, all the way up here, slowly scrolling. It says graph. The graph and the equation are given. Find the inverse and then graph it. Okay, and this is what we did last time. Here's us switching x and y and then solving. Notice, remember, we had to cross off half of it because they only graphed half of it. This looks like a parabola. It should. And if you look at this and graph it on Desmos, it'll give you a full parabola. But then they restricted the domain to the right half. Remember this? Restricting the domain to the right half. So then when you're reflecting it, you're only graphing half of that parabola, if that makes sense, right? So which half are you graphing? The positive half. The positive half. Okay. So here, you guys can kind of see the shifts of this. If I asked you, what shifts do you see? You should say something like, oh, it shifted right one and it got stretched, because you know this pattern, right? I've never taught you about radical functions. I think that's a big topic in integrated 3, perhaps, not sure. But the way I've taught you, you should be able to look at this and be like, oh, whatever that looks like, it shifted to the right one and it's stretched, vertically stretched up. Do you guys all see that? Yeah, look, it shifted right one and it's vertically stretched this way. So you should be comfortable with this. Wait, what happened here? Hold on a second. Give me 1 second. Okay. So they want us to find the inverse algebraically and then graph it. You don't have to do it in that order. You can actually graph it and then find the inverse, right? So here, if you wanted to, here, I'm going to show you how I graph it. This is what I think about in my head. The very first thing I'm going to do is I'm going to show this line. Is that pretty good? I don't know. This line is so thick. Kind of looks like this, right? Maybe up a little. I wish it would. It's kind of like, it doesn't snap. It's like snapping to a grid that doesn't really work with me. But just imagine that's the y equals x line. And can you imagine me graphing the other side of it? So actually, I'm not going to use this because it's distracting me more than anything. So the very first thing is I'm going to find a bunch of good points. Do you guys remember what I meant by good points? Can you guys mention some of my good points here? What are some good points here? You can put it in the chat. You can put it wherever. What are some good points here? Very good. Someone says 1, 0. Very good. Someone else said 2, 2. Very good. Someone else said 5, 4. Ooh, very good. So you guys are finding all these really good points. Thank you. So I'm going to take all those points. And I'm just going to start with the first one. 1, 0 turns into 0, 1. Okay, so here's my f of x. And here's my f inverse of x. You guys should recognize this. 1, 0 reflects to 0, 1, right? And this has to do with what you guys said earlier. If I'm looking at inverse, all I'm doing is switching the x and y, Miss Johnson. Absolutely. Another one of you said what? 2, 2, which is interesting because 2, 2 reflects on itself, right? And that shouldn't be a surprise because the x and the y are exactly the same. So when you reflect a point, think about a mirror. If you're touching the mirror, that point reflected is itself. Does that make sense? If that makes sense. Okay, moving on. I got, let's see. The next point you all said was 5, 4. What does 5, 4 reflect to? What does 5, 4 reflect to? Well, that color looks the same. But you guys have young eyes. Yeah, it reflects the 4, 5. So I go 4, I go 5, it goes right here. Do you guys all see how that it's like the shape is coming out there? Do you guys all see that? And is there one more point that you guys said? No, let me see. Is there another good point? Oh, there's another good point. It's 10 comma 6. So my last point that I'm going to use is 10 comma 6. That of course reflects to 6 comma 10. Oops, I forgot the parentheses there. 6 comma 10. You guys all see that shape there? Very good. You guys came out with some really good points. Very, very good. And you all know how to graph now. Miss Johnson, what about the in-betweener points? So once I have those points, I'm going to draw a curve in there. And it's not going to be perfect, especially for those of us that are drawing onto Desmos, right? Because you're drawing with the mouse, it's not good. So you're just going to do your best to draw this. And then that's it. So any questions on my graphing? Any questions on my graphing? Any questions? Miss Johnson, I don't get where you got. I don't understand. Please help me. Stop talking right now because that doesn't make sense to me. Anybody? No, we're good. Very good. Thank you for participating. All right. Yes, yes. Very good. Okay. Perfect. Okay. Oh, why didn't you put it on the other graph? So I tend to graph things along with it because I want you to see what you're supposed to see. Does anybody see what they're supposed to see here? Everybody see it? What do you see? Tell me what you see. So again, the next unit we're going to get into is geometry. One of the biggest things I tell my students that you have to get better at in geometry is observation. Very good. If you saw this reflection, can you pretend that this is the line x equals to y? Pretend that it's like sitting perfectly right in there, right? If you can see the reflection between this and this, that's exactly what you're supposed to see, right? Because that's what you guys told me. Inverse means to switch x and y. So that means it's going to be reflected across the x equals to y line. If you want to draw it on this one, by all means, go ahead. But it's easier to see it when they're on the same graph. Okay, so that moves us to finding the equation algebraically. So we go to y equals to 2 square root of x minus 1. So you guys said to switch x and y. Oops. Y. So I'm going to write x is equal to 2 square root of y minus 1. Okay, so that's the very first thing that I want you to do. Okay, everybody okay with this? So far, so good. Let me scooch you over. And then I want you to solve for y, meaning get y by itself. So I'm going to pause right here. I'm going to have you solve this one on your own. Do your best. It does not have to be perfect, but take the time. This is one of those doing things, right? Math is not it's not a spectator sport. Like if I said, hey guys, I'm going to teach you how to swing the bat and we pretend we're playing softball or baseball. And I said, I'm going to teach you how to swing the bat. I can't know if you won't know if you know how to do it until you pick up the bat and start swinging. Okay. So this is not a spectator sport. Don't watch me do it and be like, oh, I get it. No, you don't. Okay. I'll guarantee it. So right now you're solving until y is by itself. Okay, so if you didn't know what to do, no problem. Just make sure that you are taking steps of like actively trying to figure out what to do. So, two ways to go about this. So first, you can go about this the SADMEP way, or the second, which is very, very similar because both of them are doing and coming from the same exact place, is pretending that you know what y is and then doing the reverse inverse order for that. Does that make sense? So let's try that and see if you connect with that a little bit better. So can you pretend off to the side? So this is me pretending that you know what y is. Someone give me a number for y. What's a number for y? Any number. Don't give me the answer though. Okay, very good. So yeah, someone says the number 6. Let's go with 6. So ask yourself, what would you do to 6 first? Like what would you do to 6 first? So first, let's see, let's make a little list. Oh, I want to move this, sorry. I want to move this up here because then I can write my list here. So what would you do to 6 first? What would you do to 6 first? Look at this. What would I do to 6 first? Yeah, I would subtract, right? So number 1, I would subtract. Subtract what? 1, right? I would subtract 1. So now I have that this is whatever, 5 square root 2. Well, then what would I do? What would I do with that 5? Now what would I do? What would I do next? And I know it seems like obvious, like, okay, you wouldn't divide. I'm saying if you look at this expression right here, it says 2, well, it's supposed to say 2 square root 5. There it goes. What would you do with the 5 next? Yeah, I'd take the square root. So then I'm going to put square root. So let's pretend that number comes out. It's 2, I don't know, whatever. It's 2 point something. What's the last step that you would do? What's the last step that you do? What's the last step you would do? What's the last step that you would do? Looking at this, what's the last thing that you would do? Yeah, you just multiply. All right, so this is that order that I was talking about the other day. So the first thing I do is I take the pen, I put it in the box. Then I close the box, and then I hand you the box. Everybody okay with that? So what you do first is what I did last, but you're going to undo it. Does that make sense? You're going to undo it. Is everybody with me on this? Yes? Yes. Thank you for nodding your head. Yes. Come back to me if you lost. If you got lost, come back. Thank you. Thank you for my thumbs up. So the first thing that I did is the last thing that you'll do. Yes. So the last thing that I did is the first thing that you do, except you're going to undo them. So we're going to go in this order, right? We're going to start with the last thing. So the last will be first is basically what I'm saying. So, but I'm not going to multiply. I'm going to undo it, right? So the first thing that the last thing I did is I gave you the box, and the first thing you did was take the box. So how do you undo multiplication? How do you undo multiplication? Yeah, you divide. Divide by what? Divide by what? Divide by what? What am I dividing by, guys? What am I dividing by? Here, what am I dividing by? Look. Yeah, I'm dividing by 2. Why are you dividing by 2? It's the same reason that we multiplied by 2 before, because these 2 are going to divide out and it's going to be 1, right? 2 divided by 2, I like to draw my little cartoon ones. It looks very funny whenever it's slanted like this. But can you imagine that that's a 1? So it's 1 times the square root of something, right? Oh, Miss Johnson, but it's a fraction. We don't care. We actually don't care that it's a fraction. So x over 2 equals to the square root of y minus 1. Okay, the next thing. So the next thing I did, so I put the pen in the box. I closed the box. So now you're going to undo closing the box. How do you undo that? How do you undo the square root? How do I undo square root? How do I undo square root? So what's the inverse of square rooting? Not the outverse. Nice try. Get rid of what's in the box? No. How do you get rid? So what the other way that I can ask this is, when you use a square root, what are you trying to get rid of? Yeah, by squaring it. So you're going to square it. If you didn't know this, now you do. If you didn't know this, now you do. Ready? To get rid of the square root, we square it. To get rid of the square root, we square it. So let's go over our inverses really quick. I'm going to say something. You're going to say the inverse. Ready? Adding. Yeah, subtracting. Very good. Let's try another one. Dividing. Yes, multiplying. Okay, last one. Square rooting. Square rooting. Okay, those are your only operations. By this time next year, you will have probably another two. You will have two more that you will know. So right now, if those have anything, adding, you know to subtract. Subtract, you know to add. Multiply, divide, divide, multiply, squaring, square rooting, square rooting, squaring. Does that make sense? So those are your only three. So when you get stuck on the test, be like, wait, is this one of those squaring ones? And it's true if it's a square root. Okay, let's move on. So squared and square root get rid of each other. If you don't believe me, someone give me a number. Someone get 7, perfect. So if I take the number 7 and I square root it and then I square it, what do I get? What's the square root of 7 squared? So if you don't believe me, how do I get there? If you don't believe me, let me see this really quick. Oh, wait, I had it right here. Let's do this really quick. Let's do this square root of 7. What's the square? Yeah, exactly. The square root of 7 squared, Miss Johnson. What is that? What? It's 7. What? Right? And then if I take that squared on the inside and put 7 squared, right? What if I put the squared here? Right? What if I put the squared here? It's still 7, right? Because they're undoing each other. That's like me going 7 divided by 7. Oh, whatever. 4 times 7 divided by 7. Yeah, it stays the same because those two are inverses of each other. They undo. Just like me closing the box and you opening the box. They undo each other. Okay, very good. So then those two cancel. And then last but not least, the last thing I have to take care of is subtracting 1. How do you undo? Absolutely. How do you undo subtract 1? How do you undo subtract 1? Undo. How do I undo that? Oops. Yeah, you just add 1. Okay, so wait, sorry. I needed to write this down again. Y minus 1. So we add 1 to both sides. So we get x over 2 quantity squared plus 1. This looks funny. Sorry. There you go. There's your answer. So you're saying if I graph this, Miss Johnson? Yeah, let's graph it. Let's graph it. What am I doing here? I'm trying to make this smaller so I could just grab this guy. Ah, where did you go? Why are you so gigantic right now here? There you go. Okay, so let me graph both of these and see what I get. So this one says, I'm not on the right page here. I think it's this one. Yeah. So I'm going to graph this one, 2 square root of x minus 1. And then over here, I'm going to graph this guy, which is quantity of x over 2 quantity squared. Oops. And then I get plus 1. Everybody okay with that? So doesn't that kind of, and that keyword there is kind of, doesn't that kind of look like what we drew here? Everyone's like, yeah, it kind of looks like that. When I did it, I got 1 over 2x. Yeah, 1 over 2. Someone said, hey, Ms. Johnson, can I write it as 1 over 2x? Yes, but make sure that you're, I prefer you to write it as x over 2 so you're comfortable with that. But if your 1 over 2x looks like this, that's fine, but not like this. Not like this, right? This one says I'm dividing by x. This one says I'm multiplying by x. So this one, no, because these two don't say the same thing. This one's fine. But I will tell you right now, at knowing what I know about what you're going to learn next year, I'd prefer X over 2. But if you wrote this on the test, I'm not marking you wrong for that. No way. That's good. You are perfect. Okay. So, but something is wrong here. What is wrong here? Anybody see what's wrong here? What's wrong? This is not correct. Something's wrong with this. What do you see that's wrong? Because this blue is supposed to be a reflection of red. Is blue a reflection of red? Is blue a reflection of red? It's okay if they touch. Touching is okay. Oh, that's not what I'm saying. That sounded horribly wrong. Sorry. If the two curves intersect, that's fine. Yeah, someone said it. It you're only supposed to reflect this right side, but I have both sides. So I need to restrict the domain so it doesn't include this side. Okay, so the way I'm going to do that is I'm going to put a little curly brace, you guys know this, and I'm going to use X and I'm going to say something, right? Someone said, I only want the right side. I only want the right side. How do I write that in the math sense? How do I write that in the math sense? Yeah, someone said, oh, I like how this person said it. They said, so wait, sorry, let me get rid of this. So someone said here, this is a U shape and that's not a U shape, right? So these two aren't reflections of each other. So imagine you look in the mirror one day and all of a sudden, like you see, I don't know, what would you see? Like you saw I don't know, what would you see? Like a cup. Like instead of your reflection, it was a cup. Wouldn't you be like, oh my gosh, I turned into a cup? Or would you be like, something's wrong with this mirror? So something's wrong with this. Very good. Someone put in the chat, they said X is greater than or equal to 0. That's exactly right. So now look at me. Now judge. Doesn't blue look like a reflection of red? Doesn't blue look like a reflection of red now? Everyone's like, yeah, it totally does. So if I take this out, it doesn't look like it. Right? That's not a reflection. This is you getting up in the morning and you look in the mirror and you've turned into a cup. Like, say what? Right? No. So we put it back. There it is. Perfect. Ms. Johnson, do we have to write that here? Yes. In fact, if you don't write that, then the answer is wrong. So X is greater than or equal to 0. You can put the word domain. So the domain is X is greater than or equal to 0, then we're good. How do we get the domain? So the reason why, I don't know, someone tell me, why do you think it's X is greater than or equal to 0? This is a pretty good discussion point right here. It's okay. It's okay. You didn't miss much. So why is it X is greater than or equal to 0? So someone said, how do we get the domain? So that's a really good question. I am going to stare at this one. Yeah. So looking at this, look at your function. So doesn't it make sense when I say things like this? Like, so you want to know about the domain of the inverse. Where would you get that from your function? You told me about switching X and Y. So where would if I think about the domain for the inverse, what should I look at for the function? Think about switch X and Y. Think about that switching X and Y. Where would I get that from? Which values should I look at? If I wanted to consider the domain of the inverse for the function, whose value should I be looking at? Domain is which letter? Domain is which letter, guys? Domain is which letter? Which letter are we talking about? Very good. Domain is the X. And what did you tell me to do with X and Y? Right? What did you tell me? switch it, right? So if you're asking about the inverses x's, you should look at your functions what? X? Which one? Come on, I'm walking you through this. Ready? You told me what do I do when I say inverse? What did you tell me to do? Yeah, switch them. Okay, so you're asking me where to get the domain for my function inverse? You're asking me where should I get my domains, my functions domain for the inverse? My functions inverse domain? I don't know how to put that. The domain for my function inverse? So the domain is what letter again? You said X, right? And you told me to switch X and Y, right? So who should I be looking at for my function? Yes, I should be looking at the Y's. So look at your range for your function. That's going to tell you about your domain for your inverse. I'm going to say it again. Wait, let's write this down. Maybe this is better written down. The domain for my of my function inverse is the blank for my function. So you guys fill in that blank, see if that makes sense. It's bigger, highlighted, so you guys can find it. I should be looking at the range or the Y's. Wait, maybe I should put this all in caps too. Hold on a second. Let's make this very obvious. So if I want to look at the domain for the inverse, I'm going to look at the range for my function. Doesn't that make sense? Because you told me, Ms. Johnson, if you want to find anything for your inverse, just switch your X and Y. So wait, what? If I want to find the domain, the X's, I want to know about the X's. You told me to switch everything. So look at the Y's. Yeah, look at your Y's. So the lowest Y I have is 0. The highest Y I have is infinity. So that's exactly what this says, right? So let's continue this thought. What if I wanted to know the range? How do I find the range of my function inverse is the what? Is the what for my function? Is the what? What would that be? What should I put right there? If I want to find the range of my inverse, who should I be looking at? The range, yeah, the domain, or also known as my x's, not nines. Sorry, hold on. It's slower, Mrs. Johnson. So maybe let's make this a tad more obvious. This should say x's. This should say y's. Is everybody seeing this? This should be a huge, oh, that makes sense. So if I want to know about the domain for my inverse, I should be looking at the range for my function. So if I'm looking for the domain of my inverse, I should be looking at the other guy's range. And you switch them. Why are you switching them, Miss Johnson? You keep telling me every time I say inverse, you're like, switch it, Miss Johnson, switch it. When I said graph it, you said switch it. When I said find it, you said switch it. So it just means inverse, right? Inverse, you should be thinking of that. Yeah, and reflection works too, right? Like if you think about this statement, it's kind of like that one statement. I forget what these statements are called. I learned about them. There's a specific name for them. It's like what's his name's quote? Don't ask what your country could do for you. Ask what you could do for your country. You're just switching things, right? So remember that here, because that's exactly what we're doing. In inverse, we're just switching. So if you get confused on the test, go back to your definition. So my students always ask me, hey, Ms. Johnson, how do you square a function? Well, what does squaring mean? So can you apply that to this fraction? Oh, totally. Right. Okay, let's do this. So switching again. So keep this in your mind. I need to fast forward. All right, let's move. So you guys should be good there. We're good there. Oh, checking it. Darn. So we checked it graphically. You can also check it algebraically. Do you guys remember how to check it algebraically? Just plug him into him and him into him. Plug your function into here and plug this into your function and see what you get. So really quickly, I want to do that. Can I do that? Yeah, I'm going to make this a little bit smaller so you can see a little bit more. I think I want to erase this and I'm going to write right over that. That's what I'm going to do. So this is me checking. So this is the reason why I love math so much, is because I can check my answer and make sure that I'm right. I like being right. When I argue with people, I want to be right. I don't want to be, I don't know if I'm really right. I don't ever want to turn in a test. I'm like, I think I'm okay. No, I want to know that I'm like right. Okay. So when I'm checking my answer, this is what I'm going to do. I'm going to take f of x and plug f of x into it. I said that wrong. I'm going to take f of x and I'm going to plug my inverse into it. This looks really confusing. Okay, this looks really confusing. But all I'm saying is I'm going to take this whole thing right here. Like, can I do that right now? I think I'm going to do that. Hold on. I'm going to take that whole thing. So I'm going to take f of x, which is 2 square root of, and I'm going to leave a big old parenthesis right here, minus 1. And I'm going to take this whole thing right here. Can I be that lazy? Can I really be that lazy? I can. And I'm going to take him and I'm going to put him right here. That's literally how you're going to check your function and your function inverse. Do you guys see what I just did there? And you're like, so what, Miss Johnson? So what? I'm going to show you what. Okay. So now I'm going to simplify this and I want to see what happens. Does anybody see anything that you could do? By the way, you are so impressing me right now. Some of you paying attention like I've never seen you pay attention. Is it going to pay off? I hope so. I know so, actually. So don't doubt yourself. Just keep going. Does anybody see anything you could do here? What do you see that you can do? I'm looking for something to do. I'm looking for something to do. Yeah, +1, -1, Miss Johnson. Isn't that 0? Yes. So I'm gonna just rewrite it. I'm gonna ignore that then. Square root of x over 2 squared. So then again, you're gonna look for, okay, what else can I get rid of? What else can I get rid of? Very strong work there, guys. Very strong work. Okay, keep going. What else can I get rid of? Oh, you can't see it because my iPad is slower. Hopefully you can just pretend that you see this part under there. Can you just pretend? Yeah. What happens to this squared? Remember what we did over here? What happened to the squared and the square root? What happens to them? Yeah, they undo each other. So Miss Johnson, I could just kind of cancel them out. Sure, let's do that. So you're saying the square root cancels with the squared. Yes, that's what you guys told me over here, right? We wrote this in the calculator and it came out to be 7. So you're saying, Miss Johnson, the only thing that's left is that 2 and then the x over 2. That's all that's left? Yeah. Okay, now what do you see happening? Anybody see what happens? Anybody see what happens? What happens? Yeah, these cancel, right? This is my other number 1. I know you guys make fun of my ones right here. This is a 1, right? 2 divided by 2 is just 1. So Miss Johnson, I'm just left with x. Yes. And this is when Miss Johnson's very happy. Why is she happy? Because if you plug a function into its inverse, you guys told me that they undo each other. They undo each other and they just leave this number 7, right? So same thing goes here. If I plug a inverse into a function or vice versa, I should just be left with x. Yay, Miss Johnson, I'm done. I'm done. Okay. Technically, if we had more time, I would make you plug this guy into here, into this x, and you'll see the same thing happens. Okay, so I'm going to continue so that we can move on. We can do our little takeaways really quick. Where are you, takeaways? Did I pass the takeaways? I did, huh? Where are you, takeaways? Oh, by the way, for this, if you ever get a chance, read these because these are really good summaries. So it says in this lesson, we learned the equation of an inverse function will contain the inverse operations in the reverse order. We talked about this over and over again, right? We're undoing in the opposite order that we do. We use this idea to find a procedure to solve the equation of the inverse of a function. Okay. All right, let's see. The takeaways. It says finding inverse functions algebraically. I've given you two different methods, okay? And I don't know which one you like better. One of the methods that we used was SADMEP, right? One of the methods was SADMEP. I have a feeling you guys liked this way better, where you pretend you know the number and then you make a list and then you undo it going up. Did you like this way better or SADMEP better? So sorry. SADMEP or this way? Yeah, this was way easier. Okay. So when you do this, you're just picking a random number and then you say, what's happening to that six? And then you write it down, subtract one. And then you say, okay, well, now what's happening to that number? And you said square root. And then now what's happening to that number? Oh, we multiplied. And then you go in reverse order in inverse order. So reverse, inverse order. Got it? Or inverse, the reverse order. Inverse in reverse order. Something like that. All right, so that means we are done with this section. Hopefully, it was a really good review, and we will end this